G'day guys. Well, that GPX 4500 I gave it a run out in the bush. Was absolutely amazing. It really so quiet, powerful, punchy, killed hot rocks, no problem. So yeah, we've just extended what we did with that on a couple of detectors. I've got one here on the bench. I don't know if you can see it there, but you probably might recognize that thing. I don't know if you can see it. Where do I poke it? There, that thing there. Yeah, that's a GP Extreme, and I've given that the treatment as well. It's sitting there running at the moment, and quite quiet. I'll just bring this over. It's a little bit far away. There we go. Come on, earthquake. So yeah, I don't know if I can't do it on that camera. Can I? I can't expand it. Not to worry, but I don't know if you can even see that screen. It's probably very small. But this one here, I put variable frequency in this one. You can probably see the screen move. Well, how about I turn that down for a start? Yeah, I think you can probably see the pulse widths on there expand. I think they go from 29 microseconds on the transmit pulses up to whatever they went to. I don't know. Let's have a look. Sorry, I've got this one running at 27 microseconds, and it's running beautifully. So let's crank up the frequency, and we'll measure it out. Yeah, I'm going to probably pad that a little bit. So yeah, 27 to 35. Probably want to go a little bit more than that. So I'll adjust that and probably get it up to 38, 40. So we'll get it from 27 odd up to 40 microseconds, which is really good for very tiny gold, of course, and very big gold. Yeah, so that's it running away. Put it on small gold and variable gain. Even about a third gain, I can give you a bit of a look-see. It's amazing. You don't realise how good these old detectors are. But there we are. Oh, God, it's an old whatever. But the funny thing is, even in normal mode, this thing, it blows away a standard 5,000 on some gold. I'm sorry for saying that, but it actually does. We'll go up. I'll show you. So we'll, I've got to loosen that a bit. There we go. So there's our coil. Okay, I'll turn the audio back up on that. Not that there's much 0.05. Yeah, I'll put this microphone near over near the speaker a little bit. So there you go. You have a listen to that. Ready? A little bit of noise, but I haven't really trimmed up the frequency or anything. Let's put the gain up a little bit more. We'll see what we get out of it. All DC levels changing in indicators cause that, so you can't do anything about it. As soon as you move anything like that in the gain stage of the detector, it's going to howl. But anyway. I mean, that smashes everything. With an old detector, an old GP Extreme, and you'd say, what's it going to do when we get a hot rock? I'll bring the microphone back up here because you probably can't hear me. I should have had two mics on. Hang on. I'll click that on there. Hopefully you can still hear the detector. I've got a fan there going too, blowing cold egg. It's pretty hot. It's right near the coil too. Not a good idea, but hot rock, Kalgoorlie hot rock. Let's stick it into fixed, back into tracking. One more flick and back. Just a noise. So it tracks beautifully. And we've got a ton more gain we can get out of this as well. I'll just crank it all the way up. How's that? Here we go. Okay. I call this flat biscuit, right? Now, even I've got the damn fan there, but anyway, this will give you an idea. This is highest frequency. Everything's flat out. Any interference in this workshop's going to get in. You can't do anything about it. 0.05. It'll probably overload. Let's see. Okay. If we didn't have noise from all the interference, yeah, it's absolutely kill. So we get a hot rock, we get a Kalgoorlie hot rock, one of the worst things ever made, or invented, or created. And I'll just flick this into fixed, back in the tracking, and see if we get rid of that. Not a problem. And so, do you mean? So flat out, turn it off. So flat out, the detector I've got I'm running as much gain. I'm clocking it as fast as I possibly can. Yeah, with the new little tricks, big tricks. There we go. Oh, dear me. That absolutely smashed it out of the ballpark. That is a really good detector. So that's it. And let's make sure. Yeah, it's a GP Extreme. How's that? It absolutely, for normal mode operation, that's just blowing everything out of the water. So, yeah, John, it's your detector. I won't say last names, but belongs to a guy called John. So, yeah, it's all ready to get done and should be good. Now, the other thing is, too, the 5,000 that was, it's gone back anyway to whoever owned it. God, I can't remember the name. Should do, but yep. I know there's a couple of 7,000s gone back, and that detector plus other things, and I got more in up there too. David come round. I'm not going to show them because we've got names and addresses facing us. So the interesting thing is, when I did all that extensive modification to that 5,000, which the customer's one, right? I went and did the same to mine, my own one. And if you want to see it, I can only do it in here. I was going to go out and do it in the field, but I just ran out of time and it's still in bits. But I can hook it up on the bench. That one there, I just got to clean up all the circuitry and the electronics in it. So we'll disconnect him. Yeah, I accidentally cooked one of our batteries. So I had to repair the protection board. I won't say what happened. It's really embarrassing. But it's really easy to do on the GPX plugs. Screwdrivers go in here, but a little offcut with a bend in it went into the damn supply output wires of this and shorted it out. So yeah, it did current limit, but it took out the current limiter. So I had to fix it. So anyway, I've got no case because when we build these battery packs up, once that cable goes through, you can't get it out. So anyway, and yeah, I thought too, I've never really looked at the these batteries, these particular ones. If you have a look, you got a little board on the bottom with you can charge these with USB, by the way, as well. So it's got a voltage converter on the bottom of the battery. It basically lives in there, and also it has a button you push and it tells you how much charge is in the battery. So yeah, you can utilize this as a 5-volt supply and charge it via 5 volt, steps the voltage up over 8 volts and charges the cells. So I love these batteries. These are unreal. That's what we sell on our website, Detector Mods, for all the Minelabs from SD2000 all the way up. Well, we don't do the batteries for the ones that go in the back of the detector, but we have been able to obtain some through dubious sources on the Let's Copy Everything market, and they seem okay. So yeah, these ones we make up for the GPXs, 45,000 GPs, SDs, and yeah, seems to be quite good. I was really amazed that you could charge it up with USB. I didn't realise that it actually had a complete, what's probably a SEPEC converter on the back, which means it's a buck boost. It probably will charge the battery with whatever voltage you want to give the thing within reason. Probably give it 4 volts, probably up to, I don't know, 15, 16 volts. It'll probably charge. So it's that board there is an all regulator board, even though these come with their own dedicated charger. So anyway, I'll put that there. I don't want to short that out. That will cause a lot of smoke, and yeah, I'd have to somehow grab it and throw it out the front door. I've done that before with batteries. I had one actually go up, a lithium battery. The insulation around the tip of one of the cells, what had happened is it somehow worked itself away, and the bus bar from the negative end pushed on across the positive and the negative on one of the cells, and oh my god, all I saw was this massive red glow, smoke starting to come, and yeah, I quickly grabbed it. Lucky it didn't blow my fingers off, but I threw it out the front door, and yeah, it went up in flames. It was quite spectacular. So you've got to be careful with lithium batteries. These ones here, the newer technology lithiums are better. They don't explode as much. So you just got to make sure it's a new technology. Anyway, I will get this one here, this GP Extreme, and excuse the noise, but I've got to keep it in one piece. I don't want to stress the interconnects on the boards. But over here, I've got so many damn detectors up on the bench, I've got to move them all over the place. But I want that. There's that part. And this one here, this is my 5, which has a variable gain in it. So the circuitry in this is exactly the same as the other one I did, the 5 without the variable gain, even though it works so damn well, really impressive. But this one's got variable gain. So let's give it a bench test. I know it's going to work really well anyway, but we're going to do it. This has had a lot of work done on this. But I'll stick that in there. And I've got to get myself the right battery, don't I? So, what do we got? There we go. This is one of our older batteries that hasn't got the digital display on the bottom. That battery is probably over 12 years old and holds as much charge as the day I ever started using it. So, yeah, that's one of our GPX ones. Got to be careful. Any metal goes in there, it shorts the battery out. And actually, it actually did occur. It shorted out in here, but I had it connected up to our booster, audio booster. And of course, what do you think happened? It shoved the volts up the audio input lines and blew the booster up as well. So just be careful. You should get your little plastic cover for these. Yeah. Itchy throat. So let's plug this thing together and we'll just see what we get out of it, because I'm pretty sure it's going to be good. In there, we better plug some audio in. So we'll use our expander compressor booster and we'll hook a coil up. Hook up the double D. Okay, I'm not even going to do it up. I'm just going to push it all together. We'll just check what we got. We'll get on deep. We can put in normal timings. I can use special. Doesn't make much difference. We'll leave it in tracking and turn it on. You can probably see the pulses jump up on the oscilloscope there. Now this one here, this thing had the mods in it. It absolutely hammers. It's really, really good. It's up on, I don't know if you can hear that. Listen how quiet it is. It's unbelievably quiet. I'll just crank everything right up. It's full. That's full audio on this detector. It's in normal mode. And I'll just check the timing on it. Gee, she's fast, this one. Yeah. I got the pulse length down to 25.4 microseconds, or 4.5. I could probably go further, but what happens is you start encroaching on the flyback, and if you do that, the whole thing will go noisy and it won't work. It will stuff it up. It has troubles with cancelling out earth field, and it also have trouble ground balancing. But we'll have a look at this one. Where's my gain? It's only running a little bit of gain. Oh, we'll leave it on low gain. I'll turn the gain all the way down. I'll just show you how sensitive this thing is. I'll wind this up again, so bear with me. I really wanted to get out in the goldfields and do this one, but no, well, you know, I've got so much work on it at the moment, it's pretty hard to escape. Yes, all these detectors keep staring. David said people are going, I want my detector back on Friday when they're in Queensland. I don't think I can do that. I don't want to rush it and everything. When you rush things, it goes pear-shaped. Well, first of all, let's see. It's in normal mode. Let's make sure. Yes, it is. And we'll give it the Kalgoorlie hot rock treatment. Okay, fixed. Tracking. Go. There you go, track straight out. Not a murmur. Doesn't care. That's normal mode too. But what we'll do, we'll see how far we can get it up. 0.05. You know these detectors, you can't even hear that on a standard one. It will just, you can basically just scrub the coil like that. We'll see how we go, just for a little bit of gain. Little bit of gain, we're getting it about there. So let's put the gain up. I haven't got the microphone near the speaker, so hopefully it picks it up. It's probably about half. Well, I'll take the speaker, this microphone off, I'll put it near the detector. Listen how quiet it is. That's amazing. So I'm going to have to turn around and talk at this when I'm doing this. But anyway, 0.05. Still getting it. Out there. Crank it more. We'll see how far up we can go. Okay. I'm guessing we're about 3/4. Out there. Go a bit more. Okay, that's flat out. So that's flat out gain now. About there. So that's a good way up. That's in normal mode. It's nothing fancy. Sorry, microphone's over here. Okay, I'm going to put the microphone up here. Hopefully, if I put it like that, maybe it hears everything. Let's see. Try that. Anyway, that is right up. That's normal mode. Now, I'll crank the gain down again. I'll stick it in the special fine, right? So special fine. I'll just give it a ground bell, see how she goes. Doesn't care less. Let's crank the gain up. I don't know where I am, probably about halfway. We'll just do the hot rock again. We'll do everything in a sequence. Doesn't care less. What hot rock? 0.05. Way up there somewhere, and I don't know what the gain is, but getting on to half. But we'll keep going a little bit more. Okay, this is about 3/4. 3/4 gain. 0.05 fine gold. Still getting it. I mean, it's getting ridiculous for that. Getting ridiculously. This is how low noise this detector is. You can hear the signals easy as. So what we'll do, we'll just give it a. Doesn't give a stuff about the hot rock. That's amazing. Anyway, I'll turn it flat out. We'll see what happens. Okay, it's flat out. I wonder how much I can get out of these detectors. Doesn't care. It does not care about the Kalgoorlie hot rock. Okay, we're going to start getting a bit of noise in the system now because that's just the nature of the beast. This is the highest frequency, highest gain. Basically, let's see, 0.05. Well, you're not going to miss that. We'll take the hot rock away. Oh, we'll leave it there. I don't know. It doesn't make any difference. So, mixing in the noise there. Still getting it though. Wow. That's pretty spectacular on a 0.05. Now, let's try a 0.1. What do you think it's going to do? It'll blow my socks off, isn't it? About there. It's right up there. So that's fine gold, cranked right out. Let's put it back into normal. I just want to see what normal does on the 0.1, to see how much of a boomer of a signal we get. But still getting it up here. But it's fighting in the noise because there's just too much electrical interference. Oh dear. So, like I said, I incorporated what I did. Let's get this microphone back. I incorporated what I did in that other detector, and that's just absolutely it. No, really, because I've been doing this for years and years and years, and that's absolutely it. Outstanding. That's outstanding performance. I'm very, very. I get impressed with my own work sometimes. Sometimes I don't, but sometimes I do. Got a tickle in the throat again. Damn it! I don't know. I reckon the kids bring this stuff home from school as they, cough on you, and the next minute you got it. So I don't know. Maybe I've had COVID twice, which was like a non-event, and then I had I poisoned myself by breathing in horrible fumes or something or other. What else have I done? I don't know. I probably got bird flu this time. But anyway, yeah, this is this 5 here, and people were asking me. I said, "Oh, if you can do that on a 5, can you do it on a 4500?" I said, "Yeah, 100%. That is not a problem. I can do this on any detector. I can even do it on old SD2000 if you want." Which we have done, and we do, because people want to look for really big gold, and they love the manual ground balance, so you can do a ground balance offset. It's really good for finding mineralized ground in old buried river systems, shallow leads we'll call them, or paleo channels, where all the heavies from millions of years have all gone across the land and gone to a depression or an old creek, river, or whatever, and gets covered up and dries up, and the river or creek or whatever's moved course over that way, 5 million years ago. And these things are there buried, and they're all full of gold. A lot of heavy minerals and gold. So you don't look for the gold, you look for the increase in noise when you sweep it, when you offset the ground balance to the positive. So, been there, done that. That's all good fun. You can find some interesting things. Found a old buried, you call it a lead, but it was more of a river bottom in Creswick, out near where they dug it all up to make house bricks, which I'm very, very not impressed with. But anybody around central Victoria who bought Selkirk's bricks will probably have a lot of gold in the bricks, because it was all in pipe clay. There was gold everywhere. Like I said, I spent half a day there and filled half a coffee jar of small Sperry gold. And I went back to that spot, and it was a massive, a big pit full of water. They went and dug up all the pipe clay and made it into house bricks. I reckon they run a side business. No, I don't know for sure. I'm just saying this, but I know a lot of people who do. Uh, what do we call it? We'll call it sand, gravel, stuff like that, and they have a works permit to do the basically road-based stuff like that because we need it. Pretty easy to get a permit to do road-based, but I reckon they're all running side operations, getting gold out of the ground. Well, actually, they are. I know a few of them, but that was a long time ago. I don't know if they're still doing it, but yeah. What you're doing, you get onto the basement, and you don't go and turn that into road base. You get what is there, probably the last 6 inches or so, scoop it up and put it in a wash plant. And yeah, some people have done very well doing that. So you get your works order, works permit, and yeah, start your own little gold mining operation on the side. Maybe I shouldn't have said that. Maybe people are going to crucify me for saying that, but that's true. And I don't think any people in certain government departments look at my videos. Maybe they do. I don't know. But no, I was just saying it's really easy to do. If you want to go and just say you're doing road base, or you're doing crushed rock for the railway track, stuff like that. It's usually a walk in the park. I'm going to die one of these days. The bloody tickle right in here. Oh, God. So I better not laugh. I better not make any funnies because, yeah, I'll end up in a coughing fit. Okay. So anyway, apart from that, there you go. That is the beast sitting there. That goes really well. That is awesome. Now, I could spend a lot more time, effort, and cubic man hours on these detectors and even get more out of it. But, you know, it gets to a point where you just say to yourself, I'd rather redesign the whole thing from scratch, and it would be a lot better rather than pulling things out and replacing them and, you know, circumventing part of the design and putting other bits in around that part of the design. It's really hard. Like building something, you just get a board and you put the parts on it. These, you get the board, you got to scrape the white paint off it, which is an epoxy. Then you got to very carefully get the old bits and pieces off the board. You got to clean it all up and then check things, and then you got to put new parts in. So it's a lot of work reworking these, but God, they damn well work good. You can probably see for yourself that that's working really good. You get a normal detector and go and clock it and find gold at 26 microseconds on the well, if you do, basically, because all the pulses are different, I use normal mode as a reference pulse timing. I mean, I could go and look at the bloody what comes out the receiver and out the integrators and stuff, but I just look at, for a reference, I just look at the transmit pulse because everything is referenced off that. So standard, they're about 35 or 36 microseconds. And yeah, even trying to get fine gold at a decent gain at that when you flick it into fine gold, because all the pulses change, they come right in. I think in fine gold, there's a couple of pulses there that are probably around about eight microseconds long. It's very, very fine pulses for very tiny gold. And, you know, you got to be careful with how the whole setup is. If you did that in fine gold on a normal detector and clocked it up like that, it'll fall over. It'll get to 29. No, it won't even get there. If you put a high capacitance coil on, like an old one, it'll probably get to 30 microseconds and it won't work in fine gold. It'll just desensitize and fall over. But this one here, even though it's clocked like crazy and it's got very, very small pulses, like, you know, this is behaving like I put a counterwound winding in the coil and controlling the flyback and transitions by doing something like that, you know, like that Axiom does. And, you know, just controlling everything, controlling the current and the way things decay. You can make detectors very, very sensitive. But this doesn't need it. It just works on a normal coil. It's just as damn good. I mean, that um, well, that kills an Axiom. Sorry. Even though I said I like the Axiom, as a standard detector, it seems okay, but it can be improved, and everything can be improved. Otherwise, that wouldn't be working as well as what it does. But I'm just saying, my God, some of this old stuff, if you just put the effort into giving it the oomph, it works out really well. Unbelievable. And the thing is, even though we've been doing these upgrades for, I don't know, God, since, or when I first started doing it on early detectors, it might have been, I don't know, 94, 96, something like that, 1996, whatever, 94, somewhere around there. But before that, I was playing around with VLF. This is when the pulse inductions come out, and I started playing around with those. But we're doing VLF stuff back in the 80s, fiddling around with all that stuff and making them better. But yeah, these PIs, even what I've done with this, I guarantee you, I do a bit more R&D, a bit more research. Actually, I know how I can do it, but I have to make up subboards. I've got to make up more subboards. I was actually in the middle of designing another subboard, and I'm really, what really is a problem? It's really difficult. If I make a subboard up and I really come up with some really good innovations and I put it in these detectors, it's going to be back engineered. I guarantee you it'll get back engineered because there's some tricks that no one realizes whatsoever. They'll never realize it, what you can do with these detectors, and you can just absolutely squeeze the grunt out of them. This at the moment, this thing I just did for myself, I mean, that is unbelievable. That is just huge. But I want to go test it out in the field. I might do that tomorrow if I can. If I can put the covers back on it and get it out the door. But then I've got people screaming for their detectors. So, I want to look after people, but I also want to do my own testing. You can't do it all in the workshop. You can do a hell of a lot of it, but that thing's there. That's kicking ass. That is really kicking it hard. That is the best I've ever seen. That is just unbelievably awesome. And it also, it is a 5 as well. Where I would rather do 45s like that because I can probably get more out of it again. When you start getting very narrow, fine pulses, 5 microseconds, 8 microseconds, whatever the hell they were, it's very hard to have something that short and, dealing with the flyback from that as well. And, just the whole scenario of trying to deal with that and other pulses like that, and the voltages are like this, and the voltages are like that, which all calls for different scenarios to make it work properly. One size doesn't fit all when you have different pulse widths and power levels being fed into a common value coil, whatever it may be. Nothing is exact. So there are ways of dealing with that as well. There's ways of dealing with everything. And the thing I'm trying to do at the moment too with everything, I'm trying to make it automatic. Okay? So when you go to a mode, it's optimized for that mode. The variable gain on the front end, you really need that. You can't do what I do with these detectors and just use the gain on the back end of the detector, the post everything gain. You got to do it pretty close to the front end, because who knows what's happening at the front end? Are you in saturation because it's very mineralized ground? Well, we'll turn the back end up and down. It has no bloody effect. You've got to do it at the front end, and I don't know why a lot of manufacturers don't do that. I think in the later ones they possibly do that, but it's got black modules in there with all the hidden preamp stage. This is a preamp. Got a few other things in there, but I won't go into that at the moment. So, yeah, that's enough waffle, isn't it? I think it's quite good. I should show you the gold I could get. Oh, where is it? It might, actually, I had some gold that I got the other week. It's so small that it might have blown away with the fan here. I'm not joking. It is really small. I did weigh it. I had to use the tickled. Oh my god! See, shouldn't say it. I thought of something really funny. I was going to use the jeweler's scales. I was going to call them the cocaine scales, but people would probably believe me. Um, but yeah, you see your drug dealers with these very sensitive little scales. But the jeweler's scales I've got there go down to decimal points of, I think 3 decimal points of a gram or something. And yeah, these bits of gold, I think I showed someone who come around and they go, what? But yeah, it picks them up on the 11-inch coil. Work that out. And it ground balances and everything at the same settings. So, just, yeah. Oh, I got to do something about this throat. Jeez. I don't know. Maybe I've got the bird flu or something. Because I'll tell you what happens, right? Occasionally, people will come round and have a chat, da da da. And I'm not joking. In a day or two, some lurgy gets me. So I don't know. You prospectors, maybe you're carried very diverse and exotic diseases or something. I don't know. And yeah, I cop them. I don't know. Maybe it's the school kids. I don't know. Yeah, when I see one of the kids with us go, sniff, 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 I go, oh, God, no, I'm going to get it, aren't I? I'm going to get what they've got. And usually I will get something. But yeah, this one, I don't know. Maybe it's another dose of COVID or something, that engineered thing. I don't even think you meant to say that. Are they still cracking the wobblies about that? You talk about COVID, oh no, you can't mention COVID. Oh. Just have a look at YouTube. You want to find out all about COVID, or you look at some of Trump's picks for various departments and have a listen to what they say about COVID, or listen to Joe Rogan. You'll find out about what COVID is and where it come from. Yeah, quite a lot of knowledge there, and depends who he talks to. The other person too, if you want to know about COVID, I'm just going off course a little bit here, but it's very interesting. Go onto YouTube and look up Eric Berg, Dr. Berg, Berg. It's a very cluey guy, actually. He's a bit of a health nut. But the other day he had an interview with some vaccine expert, and it was going all over the COVID, where it came from, how it happened, how it was funded, the whole lot. It's very interesting. So look up Eric Berg or Dr. Berg. I've been watching him for years and years and years. It's quite knowledgeable. Tons of health stuff there. How to fix this and how to fix that. Anyway, yeah, it's enough waffle, isn't it? I've waffled on again, and I'm not going to get diverted about anything. So I'm going to sign out. It's 10 o'clock, and I'm going to go and pour some ethanol down here, and hopefully that takes out that lurgy. It's just something in there. It's going like this. It feels like this, and if you cough, it goes like this. I nearly did it then. See you